is actually this one, right? So already 4 people online, and today we're happy to have Tobias here with us uh, talk about velar softening and why it is real, which is actually a process that's always given as an example of a non-phonological process, and we'll see why Tobias thinks that it's real.
Hello, everybody. Hope you can see the screen behind me. So this is a talk delivered by me, but the 3 authors on that talk, which is Miriam de Jonge and Alex Chabot, who've worked on that with me. So what's at stake today? Not sure people can read the thing
Yes,
behind me. They
It
can.
only looks like this. It's only on the other way.
So there are 3 things that are at stake. So one is to have a phonology detector, an EEG-based phonology detector, meaning a protocol that is able to tell whether a truly phonological computation is involved in a given alternation. So whatever alternation you have in your language, you want to know whether whether phonological computation participates in creating that alternation. So we aim at building a detector for that, a machine that's able to tell you. And not something else that is at stake is about optimality theory, because in optimality theory there is in regular fully parallel optimality theory, there is a constant amount of computation whether the underlying form is modified or not, because you have to go through eval and you have to generate your candidates, no matter what candidate wins. So whether you modify the underlying representation or not will do the same amount of work in OT, and that will be at stake in what I do. And finally, realizational theories of morphology, like construction morphology or paradigm function morphology. One question here is whether phonological alternations in paradigms are epiphenomenal of the realization of paradigm cells rather than due to phonological computation. And if I'm not sure about the answer, actually, what these people think about phonological processes, whether there is any phonological computation left after cells have been realized. But if there is, and there is a divide between alternations that are due to paradigm cell realization and alternations that are truly phonological, then what we'll be doing may have an impact on what they say. Okay. So let's first look at our reference experiment, which has been done by Scheer et al. 2009, paper published in Science. There's Steven Pinker involved. You can see, well, can see the reference here. So they have worked with intracranial, so deep electrodes. So this is when people for medical evaluation get their skull opened and get electrodes sticked into their brain. And this explains also why they had only 3 subjects running they recorded only 3 subjects, patients implanted for medical evaluation, as you can see here. So here's the experimental protocol they ran on these 3 people. And well, that's actually the cornerstone of of all that will be following. So I spent a little time on that. Make sure everybody understands what subjects are doing when you record them. So there are 3 experimental conditions called It doesn't work probably. So-called read, null inflect, and overt inflect. And on the read condition, people are asked to repeat a word they see on the screen, okay, which you see in the first line. So there is a stimulus, what we call stimulus, and there is a target, what they are supposed to pronounce. Okay, so they sit, they are instructed to repeat a word on the screen, then they see a word on the screen, then they repeat it. And that's what they do. So, for example, if you take rock as a stimulus, then and the target is rock as well, so they have to repeat. Okay. And then in null inflect condition, you get a carrier sentence that enforces a certain version of the word to appear. So in this case, the carrier sentence is that is the, right? So they see the carrier sentence has a hole, and they are instructed to fill in the hole with the word that appears on the screen. So they have the carrier sentence that is the, and then they see rock, and then they pronounce rock. Okay, so overtly there is no difference with the read condition, but the actual difference is that you need to do inflection. I mean, in the read condition, there is no sentence. So there's no case, there is no number, there is nothing. Okay, so it isn't embedded in a sentence. And in the second condition, so in null inflect, it is embedded in a sentence. So they have to compute that word within that particular sentence. And the assumption is that generates work in the brain that isn't generated when they don't have to calculate the thing. Again, the pronunciation at the end is identical, right? You won't see anything on the surface, but you're supposed to see something in the brain.
Yeah. Somebody said maybe move up to last just right? Yes.
And then there is a third condition, which is called overt inflect. And then the carrier sentence is those are the, so you enforce the plural, and then rock appears on your screen, and then people produce rocks. Okay, and that is identical to the previous condition, except that you have an overt morpheme now. And you have to do some phonology because the underlying representation of the plural morpheme in English is z, like in trees. And if the last consonant of your stem is voiceless, is a voiceless obstruent, then you will devoice your underlying plural morpheme, and it will come out as a z, as an s. So when they pronounce rocks, they will have done everything they have done before, plus a phonological computation, or what we suppose is a phonological computation that they haven't done in the previous condition.
They will also have done some linearization, right?
They will all.
They don't do in rock.
They will also. There is an overt morpheme. That's true.
Mm-hmm.
They sure do linearization, but they do also concatenation. I mean, they do concatenate a singular morpheme, which is zero in English, right?
It's already in the analysis, right?
Sure, it's an analysis, but they do concatenation in the null inflect condition as well.
That's an assertion.
Okay, so so what that gives us is what you see on the left of the table. So what is supposed to happen is that on the read condition, you do lexical access. So you have to go to your lexicon and look up the word and then pronounce it and send it to realization. You don't do any concatenation, but because there is nothing to be concatenated with. So concatenation not with other words, not with other morphemes, and not with morphosyntactic tagging, whatever. There is no number, no gender, no nothing. And you don't do any phonology. Okay, so you have yes in the first column and no in the second column, in the two other columns.
I don't see what you think that in on working that
Because-
supposedly appears in the sentence.
because it's not embedded in a sentence.
So what? The way when you retrieve something from your lexicon, supposedly you retrieve not just the phonological.
Supposedly.
It's the
Okay,
same
no,
supposition as
no,
the-
no. That's the assumption. I'm not. That's the assumption of Sein et al. And we will
Okay.
see what that gives us on the EEG side. Well, how the brain reacts to that. I think it is a fair assumption that when you retrieve something from the lexicon without knowing in which sentence it is, that it has no properties and you haven't concatenated it with anything. So in the null inflect condition, you have you do lexical access, you do concatenation, but you don't do phonology. Okay, and in the overt condition, you do all three. You do lexical access, you do concatenation, and you do phonology. So that's the basic setup, and what in all that follows, this basic experimental protocol will be applied to other data sets, and it won't change. There's always the three experimental conditions: read, null inflect, and overt inflect. Okay, so here's the experimental design. That's just what I said in a little more detail. So there's a Q epoch where where they get the carrier sentence. If there is one, then they get a fixation cross, and it's all timed. And then there is a response epoch where they have where they see the target word, and then where they have a window where they pronounce the target. Okay. Now, one property of that experiment is that it's silent pronunciation. There is no vocalization, so they only pronounce they think of it, they pronounce in their head. And the reason for that is that if you move your jaw or anything in your head, that messes up your EEG signal. Okay, so usually when you see EEG studies, it's 95% perception. And doing production EEG is complicated. There are also people who there are techniques to try to get around this difficulty of having of moving your jaw and messing up your EEG signal. And people try to filter out the relevant noise afterwards, post hoc. But so Sein et al. Didn't do that. They did silent pronunciation. And so we try to replicate Sein et al. So we have done the same thing. So here are the results of Sein et al. Well, I don't know whether it's whether it's useful to look at them. We may. So well, I don't know. So this one shows three graphs, and the three graphs are the three experimental conditions. And you see that the red, and if you see anything, that the red and the blue are together at 320 milliseconds. The red and the blue are together, and the green is not with them. The green is different. Okay, and the green is phonology. So the green is the overt condition, right? And the red and the blue, the read and the null inflect condition, which means that at 320, you do get a lexical access, you do get concatenation, but you don't get phonology. Okay. And at 450 milliseconds, over here, the thing is different. The blue is phonology, and the red and the green is overt and read, is null and read. So the blue is overt, and here you get a specific peak of the blue, namely of the overt condition, meaning phonological activity, which is contrasts with the two other conditions. So exactly as predicted. So the brain responds to that. And at 200, I haven't shown that. At 200, you get the three graphs are together. So that's lexical access. They all have to, in all three conditions, you do lexical access. So the result of sign et al. So they did that. Basically, the reason why they did that is to show that the inverted T is real. Okay, so to show the sequential computation in the brain as predicted by the inverted T. So you first have to get the pieces from long-term memory, lexical access. Then you have to concatenate them and do morphosyntax. And only once you have done morphosyntax will you be able to do phonology. Okay, that's what the inverted T says, and that's what they show the brain does for real. Okay. Also, their results tell us something about about externalization, because they show that externalization is a supplement that you just need when you want to talk to people. Everything is in your brain, ready before everything is done before you start moving your jaw. Okay.
How can they distinguish between overt inflection and phonology?
So I repeat Joachim's question. How can they distinguish between overt inflection and phonology proper? So overt inflection is just a word for the experimental condition, and the experimental condition isolates phonology because it forces people in the English singular plural to do phonology, whereas in the null inflect condition there is no phonological computation because there is no voicing assimilation. That's what the experimental condition is for. The experimental condition isolates. The experimental condition contrasts a task they have where we are sure they don't do phonological activity, and then to another one where we are sure they have to do phonological activity.
If you have a suffix that doesn't
there is a number of questions you can contrast that with. As you will see at the end of a presentation, it would be nice to have data from analogy, for example. We don't. So let me show you what we have in the box, and then you. Okay. So an unintended side effect of Scheer et al. Is that their experimental setup allows us to isolate phonological activity in the brain. And if you recast their experimental condition into things that you call differently than concatenation, then you see that what linguists call linguists say when you do a lexical access that in read, okay, but then what linguists call when you do a lexical access, you do morphological concatenation, but no phonology, right? That could be allomorphy. So that's a description of allomorphy. Okay, you manage a phonological alternation without doing phonology, but with doing morphology. Okay, so on the table you see the example of electric and electricity. So in the second example you get if electricity is a case of allomorphy, then you get 3 items stored: electric, and idi. And then when you pronounce the word electricity, the suffix idi selects the S allomorph. Okay, so that's the description of what happens when you do a lexical access, when you do concatenation, but when you don't do phonology. Okay.
So allomorph selection is phonological.
Yeah, no, but not in this case. Not in this case. Sure, there's phonologically conditioned allomorphy, but that's a different topic. And I'm not sure whether there is allomorph selection exclusively done by phonology.
Some people might take this like
Exclusively done by phonology. That's
No,
not
but
true for
this-
the. No, that's not true for this case. It's no
of
that
course, many
there's
people
class
say-
1 and class 2 involved. It's not purely phonological.
No, but some people would say that this is some sort of the unmarked, I don't know, and then it is found. I'm not.
You will
defending
not. You will not. You would. You may have all kinds. You can say it's analogy again. Please follow what I'm saying. I'm not excluding all analyses, all possible analyses that somebody can come up with. Right? We are experimentally contrasting exactly 3 things. So one is suppletion. So because if electricity is stored as just one lexical item without being decomposed in the lexicon, right, and then it's just retrieved from the lexicon and is pronounced, this is what linguists call suppletion. Okay, what linguists call allomorphy is the case I've just described, where 3 items are recorded in the lexicon. And then no phonology is involved in the production of that thing. And then the third option is when you do regular morphophonology, namely when you get 2 items stored, electric and idi, and then when you pronounce electricity, you concatenate electric and idi, and then you perform phonology and turn the K into an S. Okay. So, and that's the exact same table as before, right? Just this time, it is linguistically informed. Okay, so actually, what Scheer et al. Allows, what Scheer et al. Setup allows, is to contrast 3 possible analyses that exist and have been proposed for various phenomena, including velar softening, and that have and that we will be able, if everything works fine, to tell apart. Okay, so the EEG will tell us whether, if we input electricity, whether we do get a lexical access, whether we do or don't get concatenation, and whether we do or don't get phonological activity. That's the goal. Okay. So what we do today is English singular plural, so the replication of Scheer et al. So we're talking about the data sets now that are analyzed. So we do English singular plural, so the replication of Scheer et al. But so what we did in Nice is scalp surface electrodes. So we haven't opened the skull of anybody. So we have done regular surface EEG. So that's a methodological and technological challenge by itself, because it's nobody guarantees that you get the same result with scalp electrodes as you get with deep electrodes. Okay? And then so this is our control set, so to speak, because it's not linguistically very informative if we come up with the same conclusion as Scheer et al. Namely that in English inflection, there is phonological computation going on. There's probably very, very few phonologists who would doubt that voicing assimilation is a truly phonological process and exists in that particular inflectional paradigm in English. But again, this is our control that we use in order to examine a paradigm that is conflictual, where people have claimed all sorts of different things. And so we have chosen them, maybe the most conflictual one, or the most famous one in English, which is velar softening. And so we run velar softening through the experimental setup you've just seen. And what we have already in our box, so for what we have data acquired and which are currently prepared for analysis, but which we don't have we can't talk about that yet, is English trisyllabic shortening or lengthening, so hostile, hostility, and English nasal cluster simplification, so sign, signing, signature, like the two other classical English processes that many people have doubted they are phonological in kind. So as I said, the goal is we build an experimental protocol that is able to detect phonological activity in an alternation, and people can come up with whatever alternation, whatever language they want, and the machine will be able to tell them whether the particular alternation they have involves or does not involve phonological activity. And the data sets one data set to come we haven't acquired yet, but we will this spring is a crazy rule in Sardinian. So L goes to R or H in intervocalic position. So this is the chapter crazy rules. So crazy rules are called crazy because they are phonetically, they make no sense phonetically speaking. And people, usually phonologists try to get them away, to throw them out of phonology because they will mess up the whatever regular theory you have of that. Okay, so now we're going for the replication of Sain et al. For the singular plural paradigm. So here is what you expect. You expect the progressive devoicing when your stem final consonant is a voiceless obstruent. You do get epenthesis that's independent of the voicing assimilation. You do get an epenthesis with s and sh and the voiced version. So you get fish, fishes. And so there is phonological activity involved here as well, but you don't get phonological activity if you just concatenate, and you don't have to modify the underlying item you have concatenated, namely the Z. So if you have a voiceless obstruent like a jobs, the assumption is, or the prediction is, there is no extra phonological activity. Or when you have a sonorant like schools, then you don't get any extra phonological activity. You don't get voicing assimilation here. Okay, so this is what the data situation. Now here's the carrier, the stimulus and the target. You know that you've seen that. So no carrier in read condition, stimulus and target identical. This is D in the null condition, and those are D in overt condition. So for each final consonant, top frequency items from the BNC, from the British National Corpus. So we did that with southeastern British natives that we flew in from London and were controlled for linguistic and other medical purposes. So for each final consonant, top frequency items from the BNC have been chosen. Frequency, it doesn't really, we don't really care for frequency. The only thing we can't have frequency normalized data sets because, as we will see, we want to have different stem final consonants. And if you have different stem final consonants, you won't be able to get the same frequency patterns. But anyway, the frequency is it may play a role if people don't know the word, for example. So we want to avoid words that people don't know because that may induce additional delay or weird things that you don't want to have in your data. Okay, only monosyllables of the shape CCVC, which means no consonant preceding the final consonant, and no vowel initial words in order to avoid the variation the in the carrier sentence. Remember, this is the rock, and we don't want to have any additional phonological activity, of course. So only consonant initial words and CVC words, or with a branching onset. No modification of the root of the plural, of course, no foot, feet, no knife, knives, and also we eliminated the final words because some English natives have epenthesis here as well, so they have deaths. Not everybody, it's kind of unpredictable. And it must be readily pluralizable, so words may be semantically weird or something, so we paid attention to have words that are really make good plurals. So the 3 experimental conditions times 80 words. So we have 80 stimulus words, and that makes 240 trials. And we did those 3 times, so that makes a data set of 720 trials. That if you put people into the lab, that takes about 60 minutes total, including 5 breaks of at least 1 minute. And we do have also catch trials. So because that's so because they have silent pronunciation, you never know what they do. They may think of the serial they saw yesterday on TV, right? Okay, so you never know. So so number one, we threaten them that we will see on the screen whether they comply, whether they do what they are supposed to do. Right, and of course, I mean, they believe that we can. Well, of course, we can see it, but we threaten them with that, and we have catch trials. So after every now and then, so 101 catch trials over the 720, where they must respond to. So, what was the last word that we asked you about, for example? So where we see that they pay attention, and at the end, we can control. We can eliminate people. I mean, entire participants or certain things they did, given their threshold on the catch trials, how they performed on the catch trials.
Did you tell them in the end?
No. So the data today are from 13 English natives. We do have 20 in our box, but the 7 additional are currently analyzed, and we'll go to the OCP in Warsaw in February in 3 weeks, where we will have 20, where we will have the data set of 20 prepared. So this is 13. It's an important thing. The more participants you have, the more reliable your data are, and the more unrelated inconsistencies in your data set are leveled out.
These words in significant days. I mean, 13 compared to 20 or
people usually, I mean, 20 is a number that you can publish with. You wouldn't publish with 5 or 10. You wouldn't. Okay, I mean, but there, see, I mean, Cyanidal did it with 3 because they were limited because they had deep electrodes. But I mean, if you can do 50, it's better. But it took us like 2 years to get that, or a year to get that into the box, right? And on top of that, we had to fly them in from England, so it's a financial issue as well. And they did all the data sets at the same time, of course. I mean, also the other ones that we won't talk about today, like the trisyllabic shortening and the, right? And so it took them 5 days. And on top of that, they went, oh my God, you don't need to know about all that. We sent them to the hospital to do an MRI, an anatomical MRI, because we want to do source localization of our EEG data. But that's a different chapter. So it took them 5 days to do all we asked them to do. Okay. Right. So here are our stimuli. So we have 20 voice, 20 voiceless, 20 sibilants, and 20 sonorants. With you see the frequencies from the BNC. So all consonants that English has are run through. Okay, so here's the result for. So that's here you see the location. This is the location of the electrode that is shown. So electrodes have names. So this is C3. So electrode C3 has recorded what you see. You get the 3 conditions, and you see at 320. At 320, the green and the blue, so the null and the overt, are distinct from the read condition, just as you saw with Cyanidal before. So read is different from null and overt because you do you do extra concatenation that you do in these two conditions, which you don't do in read. At 200, you also get an ERP. So one thing is you do get an ERP, and ERP is an evoked potential. So you do get the peaks. I mean, you could not, we could not have gotten any peak, right? Any relevant peak. So that's the replication side of the study. So at 200, you see that they are all together, just as they were with Scheer et al. Here, the two are different, and here, the two other ones are different. So at 450, I mean, it's not. I mean, it's a bigger space. It's not exactly 450. It's not clean, but that may have to do with the fact that we have 13 participants only. But anyway, you do see a difference between the overt, so the phenology, and the two others.
Mhm.
Okay, just as you had with Scheer et al. Okay, so this looks like a potentially successful replication of the Scheer et al. Results. We do get the ERPs, and they are in the way they are the same as with Scheer et al.
So in the read condition, you also include stuff like
No,
no,
there's no S.
no,
There's no plural.
in the order you have all bags, rocks.
Yes.
Yeah.
Yes. Yes. It's a mix. You won't see today. We will do that, but you won't see today. Of course, what you will want to look at is just the voiced, or just the voiceless, or just the sibilants, or just the sonorants.
Yeah, I would want to words ending with a voice.
Of course. Of course.
Because you're predicting this.
Of course. Of course, this is what you want to see. You won't see it today because we're not ready. Okay. And Scheer et al. Didn't do that. Oh, I can tell you a little more about Scheer et al. We actually don't know what the stimulus set is of Scheer et al. They don't tell in the publications. I have asked Sahin. He's responded, and he doesn't have his stimulus set. It's gone. So nobody will ever know what stimulus set they have used, whether they have used only voiceless or voiced or whatever. We don't know. Yes. Yeah. Yeah. Nobody knows what the stimulus set actually was. Okay. We don't even know how many words they had. We know nothing about that. Okay. So so we did a linguistically informed stimulus set, right? And of course we will want to look at the four categories separately and in contrast, but you won't see that today. But even if you don't contrast, and so according to our prediction, of course, so there is extra phonological activity with the sibilants and with the voiceless, right? But not with the sonorants and the voice. Okay, so which means that there is actually a lot of noise in our data, right?
But despite the noise, you managed to replicate.
Exactly.
But still, you have a very specific prediction.
I know, Noam. I know. And
It's
you
really
will.
annoying that you're not telling me.
It is a preliminary thing. I'm sorry. I'm sorry. We can't. We come to Warsaw and you will see the full thing. Yeah. At the OCP in Warsaw. So I'm sorry. Of course, this is what you want to do. We will do it. We don't have the results yet, but there is an effect. So replication of Scheer et al. Is this, because we don't know what Scheer et al. Did, but we have replicated them. Okay, so now we switch to velar softening. And so here's the same thing. So carrier, stimulus, and target. And we did real words and we did nonce words. Okay, nonce words have a very interesting in that case, of course, because with nonce words you exclude any existing lexical item. Okay. So nonce words cannot do allomorphy. Nonce words cannot do suppletion. Okay, so that's excluded to start with. Okay, so this is why we put in nonce words.
And this nonce words going to be,
You will see. Wait and see. I'm just about to.
okay.
Okay, so but you need to look at the carrier. So for read, so number one, we have two suffixes that provoke velar softening, because there is a class 1, class 2 thing involved in velar softening. So idi and eyes. So idi will give nouns and eyes will give verbs. And so what they have, so in the read condition, they have no carrier, and they, as before, they see electric and they have to pronounce electric. They see public and they have to pronounce public. Okay. Pronounce it silently. In null inflect, they get a carrier, this is really, okay, and they have to pronounce electric, so this time an adjective, or public. They see public and have to pronounce public. Okay. And in the overt inflect condition, for the idi suffix, they talk about, and then they get electric, and they have to produce electricity. In the overt and for the eyes suffixes, the carrier is you need to, and they get public and they produce publicize. Okay. So again, it's like with the singular plural, the carrier enforces the kind of word you want to hear. Okay. And the same goes for the nonce words. So nectic or glyphic. So nectic gets necticity, and if they talk about nectic and then they produce necticity, and you need to glyphic and they do glyphicize. Okay. So there are actually three suffixes that produce the alternation. So idi, ism, and eyes. So idi and ism have the same parts of speech, so they produce nouns from an adjective, and hence there is a substantial risk of competing target words in the overt condition. So does the stimulus exotic elicit exotism or exoticity? Okay, so hence only one suffix can be taken, and so we made a choice for that reason. So we chose idi because it is way more frequent, and it's if you go to the English lexicon, I did the stimuli. If you go to the English lexicon and I want to come up with 80 words, right, you are in trouble. It's not easy to find 80 words. I mean, 80 words that people know, which are not chemical or whatever. Right? It's not so easy. You will see the frequencies. Many of the frequencies of the idi words is like 1 in the British National Corpus. So we chose the more convenient one lexically, idi. The third suffix, eyes, produces verbs, hence there is no risk of competing target words. Okay? And so we chose 32 idi words, 13 eyes words, so a total of 45 real words, and completed with 35 nonce words, so 18 idi and 17 eyes. Okay. So here's the stimulus set. So these are the 32 idi words. So you see electric, publics, or electricity, publicity, specificity, authenticity, elasticity, ordered by frequency, and you see that it decreases rapidly, right? Frequency of the target words. And if you go to unicity or episodicity, it's 1. Okay. Yeah. Well. Here are the real words for eyes. So criticize, publicize, politicize, romanticize, anglicize, and so forth. Okay, and you see it's also the frequency decreases rapidly, not of the stimulus word, but of the target word, of the suffix word. Okay, so here are the nonce words. So that was made up by an English native. So this is all controlled by English natives for ease. So sometimes people don't like make a plural of something, and So it's controlled by an English native. Okay, so here's the results. So it's a different electrode, as you can see. The other one was this. The first one was this one. Now we are here, okay, and we are here. But this is only 320 UC, right? It's not 450 is on a different slide. You see 200 and 320. So at 200, the three are the same, okay. At 320, we get the same effect as before. Green and blue are together against the red, and the red is read because you get concatenative activity only in green and blue. Okay, that is what this slide is supposed to show. Okay, so what that may indicate, because it's not the same electrode, but you must be super careful with that kind of reasoning. What that may indicate is that velar softening is not computed at the same place, the same location as singular pro. Okay, but you don't want to. I will never conclude that. Of course not. Its source localization is so I have to explain. The thing you record on your scalp may have an origin way distant from where you record that, right? Because the brain goes like that, and if you send a signal through that, it gets deviated in all kinds of unpredictable ways. And so it's not the case at all that what you record at electrode whatever T5 originates just below in the brain, below the point of the skull where you have recorded that. In order to know where your signal comes from, you need to do source localization. That's a complicated thing, which we will also try to do. This is why we send the people to the hospital to do an anatomic MRI. And we don't have results yet, but it's a complicated thing. So so just record that it's not the same electrode that we recorded.
That's also that you need to say how many electrodes you have and what the other electrodes have recorded, but to complete the
okay, we would need to go into detail. That's
just like about the location.
Yeah, Mohammed asks whether we would like to compare the recordings of different electrodes. So the law, so to speak, is that you can't do phishing. That's prohibited for statistical reasons. Phishing means you go look at your 64 electrodes. We did 64. So you go look at your 64 electrodes and you take whatever suits you, whatever fits your hypothesis, right? This is what is called phishing. You can't
do that.
No, you should not do that. You're not allowed to do that.
But what did you do here? How did you discover that this was
Because there is an algorithm, there's a computer program that scans the 64 electrodes and shows where there are significant differences in your experimental conditions.
the computer program?
No, well, it's not phishing because the computer program doesn't have a hypothesis. Phishing is when you pick the electrodes that suits you, that suits your hypothesis.
Yeah.
Right? The idea is to have an independent means of determining where things are going on independently of your hypothesis. Okay, so the machine tells you here is an area where things look where it seems like there are significant differences between the experimental conditions. Okay, and then you look at that area, and then you are allowed to look at this area. Okay, okay. So this is why we went to this. The machine told us in this location. Okay. So at 320, we do get what we expect to get, and at 450 as well. So, well, here it's the same. It's again a different electrode, as you see. It's not the same, right? Again, you get you get the phonology at 450 is isolated, is different from both the read and the null, as before, as in the singular plural, as with cyanide. It's the same thing.
It was the same in 450 and in 300, whatever, in the pro, right?
Yes.
You didn't change that.
Yes, it's true. So Noam says in the singular plural paradigm with our experiment, it was on the same electron. That's true. It's the case. So in principle, well, I say it in. Oh yeah, and then well, I say it now because the nonce words are coming still. So it is not unexpected, or rather expected, that concatenation and phonological computation is not done in the same location in the brain. Okay, so that is no counterindication. You kind of expect that it's not the same, well, module if you want to. It's not the same brain tissue, that it's not the same circuit in the brain that does morphophonology and that does phonology. Okay, so. Okay, so but now the nonce words are still coming. So here are the nonce words. So you have to understand this is only, so now you don't compare the 3 experimental conditions, but you compare the 2 different data sets in one experimental condition. So in the overt condition only, because we are interested in the overt condition, the one that has phonology. Okay. And what you can see is that the nonce words give you a bigger amplitude than the real words. Okay, so the nonce words are blue, and the real words are green. And the nonce words give you, they give you the same peak at the same location and time, right? So they give you the same ERP, but the amplitude is not the same. Okay, so and it's the same electrode, as before. Huh? No. You forget about the different conditions. We are only in overt condition. If I put in the 3 conditions, you would have 6 plots, right? 3 conditions times nonce words, and so you don't want to see that. We are only interested in the in what happens in the overt condition. Is that clear?
What is the overt condition?
The overt condition is when you force them to do phonology.
Okay, yeah, that's what I meant.
The colors are assigned randomly by the machine, so you don't get a fixation on red is phonology or something.
Okay.
Yeah. So, and we're looking only at that case because we want to contrast not different experimental conditions, but different word types in the same experimental condition. Right? Okay. It's like if you compared the voiced and the voiceless, for example, then you would look only at the overt condition. And okay, so here you look only at the overt condition for the nonce and the real words. Okay, so the result is that the nonce words both give you the ERP, both give you the effect, but the nonce words give you a bigger amplitude. Okay, and we'll have an interpretation of that. So here I say what I just said. So different location for different tasks is kind of expected or not unexpected. So we have parietal left for morphosyntax and central parietal right for phonology. So there is specific activity of the overt condition at 450 in both real and nonce words. And this suggests that phonological computation is involved in velar softening. So this is where the title comes from. So if you want to, there's an EEG footprint left by phonological computation, and we find that footprint when we ask people to do velar softening. They produce the EEG footprint that we have controlled for independently with a singular plural data set. Okay. So nonce words. So as I said, suppletion and allomorphy rely on lexical recordings which are absent in for nonce words, so hence the effect observed with nonce words must be phonological in kind anyway. Okay. So a competitor, which we didn't control for experimentally, is analogy. Of course, you could that's the obvious competitor. Okay. So the nonce word effect would be due to analogy, and this would then also apply to the real word effect. Okay. So we need to do that. We need to we don't know what the EEG footprint of analogy looks like. We don't know. We haven't done it. We will try to, but I mean we do one thing at a time. Again, this is 2 years of work. Well, you get a data set. You get a data set where you think that this is analogy. So, for example, I do that in class every year. You say, à l'aéroport de Nice, il y a deux. Well, everybody who lives in Nice knows that there are 2 terminals in Nice. Okay, à l'aéroport de Nice. I do that in class, and it's random. It's a random terminal or terminal, and then they fight and so forth. So okay, but this is potentially analogy, right? Okay, so you do that and you record them while they're doing them, then you'll see. Okay, but we don't know. But we will want. I mean, what you can experimental work always contrasts one thing with another thing, right? And you can't talk about something that you don't have a contrast for. You can't talk about that.
This could be a very custom analogy. Back to mention, we must infer glyphic from glyphicity.
No, you must infer glyphicity from glyphic.
Both.
You haven't.
I think both.
No, because you have never heard glyphicity.
You have to infer eclecticity from eclecticity.
No, you mean no? You have to the source of your analogy would be that doesn't need to be a nonce word. It could be a real word, right? It could be electricity. You take electricity as a base, and huh? Okay, so Joachim has doubts on the yeah. Okay, but so whatever. Maybe Joachim has doubts, and maybe there is somebody who who believes that this must be analogy, and so do the experiment, look at the footprint you get, and see whether it corresponds to regular. Because once you have your analogy data set, you can compare it to what you know how phonology works. So you can see whether you get the same footprint as what phonology does. And then you can, and if that footprint is different, then you have the footprint of analogy. Okay. So it could be analogy, but in our particular case, it is not very likely, since we know that phonological activity occurs around 450 milliseconds. And so the activity produced by analogy would need to accidentally also occur at 450. So if in our data set, analogy were at work, okay, it would have to have accidentally the exact same footprint as what we know is phonology, okay, and that's not very likely. But we can know. We need to run the analogy thing, okay. There's all the discussion you want. I'm not through completely.
It seems to me that your experiment adds something to the Sahim experiment, in the sense that in the Sahim experiment, I didn't see that there was a possibility to distinguish between concatenation and phonology.
Sure, there was. I showed that. That's the experimental design. That's a
concatenation of overt morphemes and phonology. Okay, if you have concatenation of overt morphemes in rocks, you could say that there's phonology, but you can also say what you're finding is concatenation of overt morphemes.
So
whereas in your case, in mythic, for example, there's also already concatenation of overt morphemes. Some say.
some sense, right?
The ick, you mean?
Yeah, myth and ick. So that's already a morphologically word.
Yeah.
And if you find the same thing for mythic and for rock in as in a carrier sentence, then that's significant.
Okay, I'm asked to repeat the questions because people can't hear them.
It's not a question.
Yeah, so I try to sum up the. I know the objection you've raised, which is that in the overt condition, it is not only phonology you do in the rocks example, but you also do overt morphology, whereas in the preceding condition, you don't do overt morphology. Okay, and so there are two answers to that. One that I can give right now, and another one that depends on contrasting voice and voiceless and so on. Okay, so the first answer to that question is that we know where concatenation occurs. Okay, it doesn't occur at 450. Okay, it occurs at 320. Okay, so if the overt concatenation, if it is the case, which may be the case, maybe it shouldn't be the case. I mean, on regular generative assumptions, whether you do overt or non-overt concatenation should be the same thing, because you pronounce something. I mean, the difference is just in pronunciation. Okay, so for the syntax, it should be, for the morphosyntax should be the same thing. But okay, so but even if you, so if it were true that concatenating an overt on a non-overt suffix raises different demands for the brain. Okay, if that were true, okay, they would both occur at 320. Okay, or there's reason to believe they would both occur at 320. You wouldn't expect them at 450. Okay, so that's the answer number one. Answer number two, which is not the first answer is just logical, but the second answer is experimental. So if it is the case that with voiceless consonants, we do get a 450, right? But with voiceless, with voiced, we don't. Okay. Then there is no issue of overt extra activity due to overt concatenation or not, because then we have the phonological contrast, right? Okay, so this is why it is important to be able to contrast. This is why we have included the 4 consonant sets in. Okay, so but again, I will be happy to have that to be able to show that, but I'm not right now. But it's in our box, and we will have results on that. But it is an important argument. It's an important piece in the argumentation. I have heard the objection you have raised for, I don't know, 5 years or so that I'm presenting that stuff all the time, right? So, and the way to I mean, the really the way to eliminate that is when voiced and voiceless are shown to be different. Okay.
And the thing with myth. That's what I'm saying.
Okay, so that's a different thing. Yeah. But so okay. So let me make another point. We are not comparing the presence or the absence of phonological activity, or the presence of and the absence of morphological or morphosyntactic activity. We're not doing that. We are doing a contrast between two conditions. So, for example, let's take it isn't the case, obviously it's not the case, that the only phonological operation that takes place when people pronounce rocks, right, is a progressive voicing assimilation. It's not the only thing they do in phonology. They stress, for example, they do stress placement, they do whatever, we don't know, okay? So there is no claim that our experimental condition is able to isolate this particular phonological process that we are targeting, okay? But the claim is that this process is extra on all the rest that is running. Okay. Okay, so we don't know. So there is stress assignment in English, and in other languages, whatever else is going on, phonologically speaking. But the important thing is that one more thing is going on in our overt condition than there's going on in the null condition. Okay, so we are not comparing absence versus presence. We're comparing presence versus more presence. Okay, so and that relates to your question, Noam, about mythic, which I'm repeating for the internet audience. So Noam says in mythic, as soon as you in the stimulus word ik, mythic, there is already an affix involved, ik. Okay, so couldn't that generate the extra activity? That was your question, right?
I made the remark that mythic is equivalent to rocks.
No, it's not equivalent to rocks because there is no
linearization.
In terms of linearization, there is, but not in terms of phonology. So again, if you come to the conclusion that it doesn't matter whether you do overt or covert concatenation, then it doesn't matter. Okay, it doesn't matter whether there is already a morpheme involved. Okay. So now let's go back to this difference between nonce and real words. So the greater amplitude of nonce and real words at 450 that you've seen. So real words are likely to have lexically specific behavior. So the more frequent a morphologically complex word, the higher chance it stands to be lexicalized as one single chunk. So there is psycholinguistic evidence to this end, which is quoted here. So if a word is very frequent, like electricity, for example, as opposed to unicity, it is more likely that people do suppletion with electricity, but when they have nothing stored, like unicity is not stored because they have not come across it a lot, they will use their phonological competence to derive it. Okay, so then it is probable that in a data set like that, especially when you have frequency ranges that are very different, it is likely actually that in your data set, in the real words, they are not all uniform in the routine they use in order to produce the target word. So this is what you call lexically specific behavior of different words. And of course, we don't know, but that means there is noise in our data. That means of our 45 real words, only 35 have produced have used phonology, and 10 were allomorphy or suppletion. Okay, okay, and we eliminate that noise with the nonce words. Okay, so the nonce words are pure, if you want to. Okay, so we have no lexical noise with the nonce words, and that is our interpretation of the higher amplitude for the nonce words. So the noise, so the lower amplitude, so there is less phonological activity recorded with the real words, because not all of them have actually produced phonological computation, right? But for the nonce words, all of them have done phonological computation.
Yeah, but then means that you assume that what is Karamazov say, but so you assume that frequent morphological complex words have a higher chance than if lexicalized as one single chance. Then how do you test phonology in this case if it's for like one lexical?
You don't know. You would. Oh, so the question of Mohammed is what the if it is true that there is lexically specific behavior, how do we know whether there is phonology involved or not? Okay, and we don't. We take a lexical. We take 45 words. Okay, and we don't know. We have a general prediction that the more frequent they are, right, the more chance they stand to be non-phonological, to do allomorphy or suppletion. Okay, okay, and we don't know which one does which. We don't. Okay, And then we look at the EEG footprint, and we see the relevant phonological footprint, but we see it's less amplitude, it's lower than the.
So non-squares are crucial for your registry.
No, not really, because even with the noise, we do see that there is a 450. So there is phonological activity involved. Even we don't, you know, so there are bad guys in our 45 real words, right? We don't know which ones they are, but we know that there are probably bad guys in, right? We can't identify them, so we accept that they will produce noise in our data. Okay, and then even with that noise, we do get the relevant ERP. So we know that there is phonological activity involved, not in every word, but there is. Okay, and the explanation. This is a new thing that Sign et al. Haven't done. They have not done any nonce words. So so this is our interpretation of why the nonce words give a higher amplitude, the same ERP, but a higher amplitude, because they are pure. There's no lexical noise in the nonce words. Okay. And the conclusion for what phonologists' interest is that this is all irrelevant for the question of how abstract is phonology or whether velar softening is real. What phonologists want to know is whether velar softening is a process that is present in the native competence of phonological competence of speakers, right? It doesn't matter. It doesn't matter when they make use of that competence. So for some words they may, and for others they may not, but that's irrelevant. We want to know whether English natives have a phonological process that is called velar softening. Okay, so, and the answer is, according to our data, the answer is yes. It's not always applied to all lexical items, but it's there. It's part of their competence. And if they are confronted with a nonce word, they need to recur to that competence, and they do. Okay. So the conclusion is that velar softening is present in the competence of native speakers. The debate, it's just what I said, the debate that was inconclusive for 50 years since Kiparsky's abstract phonology was about this question. So that's just repeating what I just said. So they may be in individual productions, the effective appeal to this rule, velar softening, may be lexically specific, as we've seen. So according to lexical frequency, may be speaker specific. Not all speakers need to have the same lexicalization patterns, for example. If you are an expert in whatever, and if you're an electrician, I don't know, maybe, right? And it may be token specific. So the same speaker may produce the same word in different ways on several trials. It's not excluded either. Okay. So, but these are all interesting issues to be investigated, but they do not bear on the original question, which has a positive answer. Yes, velar softening is part of the competence of native. Okay. So the consequences now. So I said in the introduction. So if extra,
You have a question.
I have a question.
Do you think that noise
Right or left hemisphere?
right?
Instead of left, where it was
rather expected.
I prefer not to say anything about localization, and it's too fishy, and I would not expect, of course, that nonce words and real words are computed in different locations. I would not expect that, of course. But that's just a personal thing. I have no means to talk about that. And again, the right-left thing with the electrode may be fooling people. So you need to do source localization in order to understand anything. So I'd rather not express myself on localization. So extra labor when underlying representations are modified. So you have an underlying representation, and that gets modified on the surface. And then the question is, what different theories say about this modification, and what they say about the demands that are raised for the brain or in the computational system. So in SPE, the amount of phonological activity depends on the number of rules you apply. The more rules you apply, the more activity you generate. And if you don't apply, if you have a vacuous derivation, then there is not much. There's significantly less phonological activity generated by your theory than if you apply 20 rules in a row. Okay. In fully parallel OT, that's not the case, as I said in the introduction, because the amount of phonological activity is the same no matter whether underlying representations are modified or not. Eval always runs and compares candidates, which are always generated. Okay, that's a known property of a computational property of OT. And so Sahin et al. Already, but our activity, our results show the reverse, of course. So you do get significant differences whether or not phonology is involved. Okay, that's the whole point of that's the whole 450 thing. Okay, you do get a specific phonological activity that the brain is carrying out. It's not the same when the brain has to compute the progressive voicing assimilation and when it doesn't. Okay, so that is a bad point for fully parallel OT, but so serial versions of OT, so OTCC or harmonic grammar, mimic rule application in the sense that more modifications of the underlying representation provokes more iterations of eval, right? And hence are compatible with the EEG-based evidence at hand. This is because they mimic rule-based, serial behavior. Right. So in terms of in OTCC terms, the derivation converges earlier if there's no more modification to be applied. Okay. So again, this is then compatible. This is just like SPE. The more your computation is generated, the more brain activity you expect. Okay. So that seems to say that a serial model of phonology is on the right track and a non-serial is not. In French, you would say c'est tiré sur une ambulance. Well, because who is doing fully parallel OT today? I'm not sure whether there is. Everybody has some serial element in. Well, but that's a different thing. So in French, I would say c'est tiré sur l'ambulance. Okay. So the ERP effect at 450 in the overt condition as compared to the read and null conditions shows that the brain responds to specific phonological activity due to the modification of the underlying representation. Okay, and the last thing is, so the realizational theories of morphology. I tried to look into that a little. So if every paradigm cell realizes a specific morphological configuration instead of being the result of concatenation, because realizational morphology says there are no morphemes, right? There is no concatenation. So if that is the case, then its phonological shape, the things that are realized in a cell, so the phonological shape of a thing that is realized in a cell should be entirely determined by its exponents, right? For every cell, you can predict the whatever phonological properties the thing has. So in this case, is there any phonological computation left that occurs after the phonological form was inserted for a particular paradigm cell? That's a real question I have. I don't know. I don't know the answer. Maybe different theories, so construction morphology, whatever, or different representatives of the same theory of realizational morphology have different answers to that. I don't know. I don't know the answer to that, but I think it's a relevant question. People must have asked that question before. So in short, if you use the full power of your realizational morphology, there is no phonological computation. That's what it means. Okay. Except in external Sandy when you cross words, because they are not real. They are not the realization of of paradigm cells. But within the word, there should be no phonology. Okay. If you use the full power, yeah. If you, no, but I'm not saying that anybody is saying that. I'm saying that this is the case if you use, in my understanding, if you use the full power and if you go down all the road of your realizational machine. Okay. Now I have looked up in the morphological in the Cambridge Handbook of Morphology, the article by Bonamy and Stump, which is called Paradigm Function Phonology, so which is a general presentation of paradigm function phonology, morphology. And I found this. So realization is a quote, realization rules of these three sorts are supplemented by morphological meta-generalizations. So that's the word they use, morphological meta-generalizations, generalizations about the phonological effects of rules of exponents. Okay. So what they call morphological meta-generalizations are generalizations about the phonological effects of rules of exponents. So that means, in my words, I would call that just phonology. Okay, they call that morphological meta-generalizations. I think I see why they call it like that, because it involves different morphemes. It's the same in different cells, so it's meta. Okay, and here are examples that they give. So phonological rules are called morphological meta-generalizations. Examples on page 460 are stem final R is lost prevocalically, or stem internal R mutates to Ö before a syllable whose nucleus is rounded. Right? So this is morphological meta-generalization in that. So that looks very much like phonology. So they do have a phonology. And then the question is, my questions would be, why are these phonological processes due to phonological computation in their mind rather than to the realization of a paradigm cell? They could be realizational. Yeah, but that's sure. Maybe that's the answer. They don't say in the article. They don't mention. They don't argue. Right? Sure. But if you go that way, then you would then the divide would be everything that is 100% regular in phonology is phonology, and all the rest is not phonology. But again, you know, what they say forever is that there is way less phonology than you think there is, because it's realizational and there is analogy. Okay. So anyway, so again, I don't know the answer, but so my question would be that, or how is it decided whether a phonological alternation is due to phonological computation or through the realization of a paradigm cell? I don't know the answer. I would like to hear representatives of paradigm function morphology to tell me what is their take on that question, right? That's the same thing. So realizational approaches appear to ascribe much less phonological alternations to phonological computation than concatenative approaches. I think that's a fair statement. So hence predictions differ, and EEG-based evidence should be able to act as a referee. So the phonology of English plural formation is not realizational, as we've seen, right? Because EEG tells us there is a specific EEG footprint of the phonological activity. So that can't be realizational then, right? And the same for velar softening. We've seen that there is phonological activity involved in velar softening, so velar softening can't be realizational. Okay. So what I mean is that the kind of EEG evidence we have, or we could potentially produce, may shed light on this divide in realizational approaches to morphology, to tell apart what is truly phonological and what is realizational. Right? And that may change their way of, I don't know, for the time being, we don't have a referee. It's just a claim. Okay. That's it. Thank you for your attention. Sure, everybody can.
So questions can be asked. It's questions can be addressed to us through chat, and we'll try to, but we'll give priority to questions after the room. There are. Yes.
For this velar software, that you get the activity of your airflow that's 450 watt. That's the thing that you say. I don't know, just a logical question. I don't know whether it is interesting or important to test cases where there is actually no velar substance and see what happens if you get an effect, logical effect or not. Like I don't know what cases where you have good at the end and it doesn't turn into stiff, or or take cases where you have S at the end, then today and see if there is any knowledge there. So have you had any?
So Mohammed asked the question, suggests that we should test experimentally cases where ID is suffixed, but no velar softening occurs because the stem final consonant is not a K. Right? Okay.
Or
antique, antiquity. There are like two words. So one thing for if you run an experiment, you need to have enough lexical material to do to make statistics out of that. So and with antiquity, that's hopeless. Okay. So what are you suggesting with what word were you suggesting? Density. Sure. Good question. Sure. We should do that. Sure. So to have a contrast, yeah, we should do that.
In the experiment,
yes. Yes. We. I went through all that. There are many words where there's more going on in the stem than just. We eliminated anything else that is going on in the stem that we can detect. Sure, we don't want to have any extra. We don't want to have any additional phonological activity.
So none of your words have the trisyllable.
No. That was controlled for. The only phonological thing, or putatively phonological thing, that is going on is velar softening in our examples.
Would you expect different effects at 450 for different phonological rules, different types of phonological rules?
Good question. I think if there is a difference, then it would be an amplitude. Not. You must distinguish what you record. You record different things in EEG. You recorded temporal events. I mean, in temporal course, you record a peak, and a peak is something that has a time course as well, and you record amplitude of that peak. Okay, so my expectation would be, or say, I don't know, say you could find a phonological process. You could find with the same suffix, depending on the stem, that one phonological process is triggered, and then in another case, two phonological processes are triggered. Right?
Or when you have it in your data, you have bucks and witches. And in witches, there is a pentasis, and in bucks, there is a simulation. So would there be a different effect? That's something that you can show us.
Yeah. Well, I actually we have, that's not the first data set we've done, but they were all experimental before, and we never reached even 13 of participants. And so I've seen already kind of preliminary data that, and of course there's not only are there two different processes like epenthesis in fishes voice assimilation, but in a serial model, they also have they are ordered, necessarily ordered. Okay, so you may expect to find the ordering in your time course. May. Okay, that would be a nice thing to have, of course, because then we have rule ordering in EEG. But even if you don't, so what I've already seen is that the epenthesis gives you a big thing, much bigger than the voice assimilation.
Because also time.
No, it's well, I would like to have a significant difference in time course, but in the data I've seen, which again are preliminary and not, I won't show them to you, right? There is no difference in time course, but there is a difference in amplitude, and a big difference in amplitude. So the epenthesis is looks like a violent thing for the brain. Well, take your people, construct the data set, put it into the machine, you will see.
You get like
Well, sure. I mean, you need technology. You need a lot of knowledge that I don't have. So you need a lot of experimental skills. And but of course, once the ice is broken, things will become more democratic in the sense that we know where to look at. You don't have to do your control. You know what you're looking for. We did that. No, we had to produce our own control. Now what we have done will be the control for other things to come. So you know what you're looking for now. Okay, and I don't know. We had trouble doing the 20 people in Nice because we had to fly them in. Right? It costs a lot of money and takes a lot of time. If you're in London, it's way easier to get 20 people in. And if you don't do 5 data sets at a time, if you do just 1 data set. So, but if you take other languages, we will take the EEG equipment to Sardinia, because we won't fly in 20 Sardinian speakers over 70 from a mountain village, right? So if you want to do whatever SEO Semitic or something, so either you find people in Paris, which you may, or to Israel, whatever. Yeah. So, okay.
Yeah, I don't know. So in the discussion, you put your findings against like theories like rule-based, as opposed to realization of pathology and that kind of things and OT. I was wondering if you had anything to say about actually, and you say that there is kind of extra phenological activity, right, due to this velar sentiment, right? So I don't know how actually representation of phenology would deal with this. What is extra phenological activity in representation the way we do it?
So I haven't understood Mohammed's question.
Donc, dans une phonologie basée sur la comment ça c'est un peu fondamentalement de l'EEG, comment on réaliserait, comment on comprendrait ce que c'est qu'une phonologie.
Okay, so now I've understood his question. His question is what is the attitude of representationally oriented theories towards that kind of EEG evidence, because EEG evidence is based on computation, not on representation. That's your question, right? Okay. It's not very, the answer is obvious. So if you believe that there is no computation in the world, right, then I don't know what to say. If you are a declarative phonologist, maybe you think of those. If there are still any around, I don't know what they. I mean, the only thing that the EEG tells them is that there is computation in the brain, right? So I don't know, but I can't understand anyway how anybody could believe that there is no computation, that how that logically even works. You have a representation stored in long-term memory, and then you concatenate, and then nothing happens, and then the surface result is different. I don't understand logically how that works. So I don't know. So for me, certainly, so you maybe you think of government phonology. Sure, it's a representationally oriented theory, but it's just that government phonology has never said much about computation. But there is computation. Government phonology does not deny that there is computation.
Oh, I think it's really weird. There's no speaker of government phonology. No, like,
What do you mean?
there's no speaker for like an official speaker for government.
Oh, Noam, come on. You can. Noam says we can't talk about government phonology because there are 500 different dialects of. Noam, come on.
No, what I'm saying is that government phonology has not spoken about it.
Of course it has. Of course it has. There are 2 papers by Jonathan Kay. Marcus will tell you about that. Sure. Sure, they have it. There is a theory of computation. It's just very small and tiny, and people have not, and there's not. So essentially, Jonathan says it's like the converging thing in harmonic grammar. You do computation until nothing else can be done, and so you can do feeding in terms of serialism. You can do feeding, but nothing else. Okay, and there's no rule ordering. Okay. Okay.
But that's something they say.
No, but you admit, Noam, that if people can talk about things that have been published, okay? So if you talk about government phonology and you look at what has been published on how computation works, you find very little, okay? And this is the reason why government phonology is rightfully said to be representationally oriented.
Other people, we don't have the right?
I don't. Again, no, but that's different. Nobody has talked. No. Nobody has talked about rule ordering here. I have talked about phonological computation. That's different. I would like to be able to distinguish in my EEG footprints what is serial and what is not. I can't for them. I would be very happy. I'm talking about phonological computation, and it doesn't matter whether your theory is serial or not or whatever, except for fully parallel OT, which seems to not be on the right track. Okay. And then, other than that, so if you are a representative of a theory that doesn't have any phonological computation and believes like realizational morphology, maybe, right? Declarative phonology, maybe, right? This shows you that you're on the wrong track. There is computation, but I don't understand anyway how anybody could believe, logically speaking, that there is no computation when people speak. It's incomprehensible to me, but I know that there are people.
Nous sommes devenus équivalents, equate, moral inflection and chronological computation.
No.
No.
So Joachim is saying, it says,
Et là où il n'y a pas de computation phonologique, parce que le the reste le bag, the trees, etc.
Right. Okay.
Et là, je crois qu'il y a un lien.
Okay, so I think there are 2 questions in what Joachim asked, and the latter question is that in the singular plural data set, there are cases where we expect phonological activity, like after voiceless obstruents, and there are cases where we don't expect phonological activity, like after sonorants, right? And then this is a mixed bag, right? So we shouldn't have mixed bags in our data, okay? That's one question, and I have already answered that. Namely, sure, there is noise in our data. It's like with the nons and real words, right? There is noise in our real words, but still we get an EEG effect. So that shows that there is something, I don't know what exactly is in our data, but even with the noise, we do get an effect. And number one. And number two, again, of course, I would like to be able to show you the comparison of voiced, voiceless, sonorants, and sibilants, which in some time, I hope I will be able to show you. But right now, I'm not. Okay, and that would be data sets without the noise you are talking about. That would be a non-mixed bag.
Les Lancelot, par exemple. Tu as dit qu'il y a une amplitude plus grande pour les Lancelot. Est-ce que ça veut dire parce qu'il y a plus de phonologie? On pourrait dire que c'est parce qu'il y a plus de concaténation.
No, because concatenation.
So, comme j'ai payé l'électricité aujourd'hui, il y a l'électricité et il n'est pas dérivé de quoi que ce soit.
Maybe. Okay, so.
Avec les Lancelot,
Okay, so Joachim is asking the question about the nonce words, whether the higher amplitude we observe in nonce words is maybe not due to the fact that real words are suppletion all the time. Right? He said, j'ai vérifié mon électricité aujourd'hui. He says électricité is suppletion, is one lexical item. Okay, so also I have already answered that question. Yes, there is noise in the data, right? And we don't know which ones of the words of the 45 words we've tested will be suppletion, which one will do allomorphy, and which one will do phonology. But some do phonology because we get a 450 effect, and concatenation is not at 450; it's at 320. You have your experimental condition. The experimental condition is there to tell you. But again, sure, there is noise. And when you remove the noise in the nonce words, then you see the higher amplitude.
Okay. So, can we find some information that is clearly not
Yeah, we need to do that. I agree.
Like what would you think?
That's not an easy thing to. That's not easy. It's not easy.
So, for example, and I said, okay, those, il faut voir comment on résout ça. Apparemment, il faut qu'on résolve ça. That is probably not phonological. Okay? It's not. Resolve, all kinds of things like that.
Sure. Again, our goal in these is to put a machine on the table that is a phonology detector or a morphology detector, but mainly a phonology detector, and then everybody can come along, like you, with what you want to know about resolve, résout, and what other people want to know about X, Y, and Z, and you just have to construct your experimental protocol. I mean, your stimuli set, which is not an easy thing to do, and you have to have enough native speakers around, right? And then you can do it. That's the goal. So it's exactly what you say. So everybody can come along. We're just beginning. We're just starting, right? We're trying to build the machine, and then everybody can use the machine. Because cheval-chevaux is not as crazy as L goes to in the vocalic position. Because you want to make the strongest case argument, the strongest case. So what would be the less probable phonological rule? Okay, so you take a crazy rule, and then Alex Chabot is doing, that's his PhD. So Alex Chabot has made an inventory in the literature about crazy rules, right? And he has an inventory, he has, I don't know, 50 crazy rules on his list, right? And they're in the in the Amazonas, they're in the right? And okay, so and then you make it, and then he wanted to test one of them, and then okay, so and in France there is no reported crazy
Well,
rule.
actually, there is something what you were going to study, right? So I'm not sure if
Like what? In the Massif Central, there are dialects who appear to do that, but they are all extinct.
no, I mean,
Yeah. Yeah.
in some northern varieties,
Realize what? Realize what? Yeah, okay, but that's way, but that's way less crazy because everybody knows Mohammed. Okay, I repeat Mohammed's question. So Mohammed is trying to find a crazy rule, crazy enough in France, and he says that in some northern varieties of French, R is realized pharyngeal, right? Okay. So, and the answer is that it's not really, it's on the craziness scale, it's very low because everybody knows that R is doing funny things. Okay. That's not very original. It's just a little further back than the regular uvula thing. Okay. It's in Sardinian, it's different because there is an independent R. Okay. You can't say this is a disguised R in Sardinia. This is really an L having become pharyngeal. That's way more crazy than.
Yeah.
So, and of course, the project is if you get a 450 footprint of the crazy Sardinian thing. Yeah, I mean, you know about substance-free phonology. Helen Rees say for 20 years, or for 30 years, 20 years, that anything can be turned into anything in any context, right? That computation is arbitrary. Right? So here's the, and then there's Jonathan Kay who says about nothing is phonological in kind. Right?
Nothing, not nothing.
Well, yeah, within a morpheme, as far as I understood, or what's in and what's out. And maybe Jonathan is listening. I don't know, maybe, but as far as I understood, as soon as there's a morpheme boundary, there is no phonology crossing morpheme boundaries.
At any rate, you don't distinguish between what they call phonology, at least in very small experiments, you don't distinguish between what they call phonology and what everybody else says is phonology.
What do you mean? What do you mean?
Because they would say, okay, maybe.
Who's they? Who's they? Uh-huh.
They would say, yes, might be phonology, even though they don't say that about that.
So Martine says she's sent you a question. So now you will tell us about her question.
I want to say this is fascinating. I have a couple of questions. Can we be sure that there is concatenation of the zero motion at Poisson rather than no action?
No, we can't. Okay, so I repeat Martine's question. So Martine's question is: can we be sure that the concatenation of a phonologically zero item? Yeah, but I'm repeating it because other people don't hear. People haven't heard the question, so I'm repeating it.
Yeah.
So may I repeat it? For so the question is. Can we be sure? So, can we be sure that concatenation of a phonologically vacuous item triggers extra activity at 320? Okay, and the answer is no. I have no clue. I have no clue what you would need to do in order to see that. Is to look at only at items that are that have no overt. Okay, so I start over again. What we suppose happens at 320. What we suppose happens at in morphosyntax is number one thing: different morphemes get glued together, get concatenated. But that's not the only thing that happens. What also happens is you determine the case, the number, whether you tag things, you build your tree. Okay, you build your morphosyntactic tree, and all that is going on when you online. Okay, and one piece of that activity is a concatenation, but that's just one piece of the activity. Okay, so I'm unable, the EEG evidence is unable to look into the bubble of morphosyntax and to tell apart what is tree building. I mean, what is regular syntactic tree building, determining what case, what number, what gender, whatever, and the action of gluing things together. I'm unable to distinguish those, because what I think I'm able to do is to say there is morphosyntactic activity at 320. I would be very happy to be able to look into the morphosyntactic bubble and to distinguish more fine-grained actions in there, like I would be very happy to look into the phonological bubble and distinguish, I don't know, palatalization from from something else, but I'm not. So we start with a macro thing, and maybe one day we'll be able to narrow into more fine-grained stuff. So another question is from Sophie. Est-ce qu'il n'y aurait pas confusion entre computation et en phono qui suppose plusieurs états, des représentations, et computation au sens neurologique qui renvoie à l'activité? Okay, so Sophie is asking whether computation in a phonological model or in a linguistic theory is able or should be equated with computation in the brain. Okay. Okay. So when I was young, there was a firewall between competence and performance. Okay. So, or take Prince and Smolensky, 93. They understand that they have that OT is kind of computationally complex, with a generation of an infinite number of candidates and the evaluation thereof. So they talk about that. They talk about that. They're very aware of that. And at that point, they just hide behind the firewall, right? That Chomsky has built for 50 years before that, and they say, we are doing a model of competence, not of performance, so we don't care what is going on in the brain. Okay. Sure. So what the computation we build into our model of competence, it has got nothing to do with what is going on anywhere in the real world, in the brain, and anywhere. Okay. It's okay, so, and that was the position of Chomsky for 50 years. To leave me alone with performance. I'm doing a theory of competence. Okay, so everybody knows, Chomsky included, everybody knows that there is, of course, a correlation between the two. There cannot be no correlation, because the brain is really doing something in real time when people speak. And it is understandable that people want to be ready to be confronted to performance, and have a theory that is solid enough to stand the confrontation. And so this is actually what Chomsky did, because in 2001, Chomsky reverted completely, and because one core motivation of face theory is the idea that an entire sentence is too big to hold in active memory, right? And this is why we need to cut it into pieces and do phases. Okay, so that's a performance motivation for face theory. Okay, And so I'm not sure about about when is a good time to allow performance to referee our competence models, but I'm sure that at some point this must come. Otherwise, we work with play money. It's play money we're working with. We can claim anything in its reverse, and we'll never be able to have a a bridge into the brain. And of course, there's a textbook by Bermudez, not Bermudez Otero, textbook by a philosopher called Bermudez, says that the challenge in cognitive science of the century is to understand in which way brainal activity and cognitive activity is related. So in which way competence correlates with performance. Okay, so if you don't believe that, if you believe that we can say anything in its reverse in our competence models and it has no relation whatsoever with performance, then all I've said is just noise to you. Okay, so no one tells me when to stop. No.
Okay, so we have to finish. Martin, if
Thank
you
you,
want to talk
everybody.
to Tobias another time. Thank you for Tobias.
Même si le paysage, effectivement, on va avoir une chronologie de ces regards, plus de rouge.